Okay, YouTube, in this video we're just basically going to explore the concept of a factorial, which in and of itself is not a sequence, but it does manifest itself in a lot of different sequence rules. And so we want to be able to evaluate for factorial values. And so we say that if n is a positive integer, then n factorial is defined as this. So the interesting thing here is what you see right here, this n exclamation point, doesn't mean n. It doesn't mean you're really excited about n, okay? You read this as, and I'm going to write this here, n factorial. So when I say n factorial, we'll just read that exclamation point. Really, it's just factorial because we're going to see things like, I guess I don't need to write a 7 here. We say this is read as 5 factorial, or for instance here, this is 8 factorial over 2 factorial times 6 factorial in parentheses. So our n factorial is defined thusly, and it's defined as 1 times 2 times 3 times 4 times n minus 1 times n, but all the way up to the value of n here. So for instance, when we talk about 5 factorial, we really mean 1 times 2 times 3 times 4 times 5, and we stop at 5. But basically, 1 times 2 times 3 times 4 times 5, all the numbers from 1 up to this value here multiplied together, that would be the value of the factorial there. So what I'm going to tell you is, while this rule is very, very true, I find it's a lot more convenient when you write factorials to start with the n value here. So for instance, our value of n in this n factorial is 5, and then count your way down. So 5 times 4 times 3 times 2 times 1 would equal our n factorial. And so we could do this in pieces. We'd say this is 20 times 3 here. 20 times 3 is 60, 60 times 2 is 120, 120 times 1 is 120. So we get 120 is the value of this factorial, and you can see how factorial values, if you sit and you list, your factorial values, like 1 factorial. Why don't we list a few of these here? We say that's 1. 2 factorial is equal to, of course, 2. 2 times 1 is 2. Let me write this out here. 2 times 1 is 2. We'll write just a few of these out here so you can see the pattern here. We have 3 times 2 times 1, which is 3 times basically the product I got in the last one, which equaled 2. So 3 times the last product, it'd be 6. 4 factorial, if I'm going to use the same logic here, I'm just going to write 4 factorial is really 4 times the last thing here, 3 times 2 times 1, which is 6. So 4 times 6 is 24. 5 factorial we see would be 5 times the last product here, which is 120 is what we saw. We'll do, maybe a couple more here. 6 factorial would be 6 times 120 is 720. And actually, I just decided that I'm going to stop right there because we're going to talk about how we can get this on a calculator anyways. But basically, the special case here we want to recognize is this one here. 0 factorial will always be defined as 1. So as far as factorials are concerned, 5 factorials, 5 times 4 times 3 times 2 times 1, we definitely get 120 here. For something like this, a rational expression, here's what we're going to do. We're going to write it, first of all, vertically oriented. And the second thing I want to mention here is we have to get used to the fact that 8 factorial, I'm going to write my work out here, and you can certainly do this, but I wouldn't do this on a normal situation here. I'll tell you how I would do it normally, but what I want you to see is the pattern that occurs here. What we're going to get is this, or 2 factorial, which is 2 times 1. That's 2 times 1. Times, now 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. So I'm going to tell you a big mistake that I see is that people think that 8 factorial over 2 factorial, 6 factorial is a situation where, maybe I'll do this. They say, well, hey, 2 goes into 8, so this is 4 factorial, and this is 1 factorial, right? And like this has a 2 that goes into it, and so does this, so that's 2 factorial and 3 factorial, so 2 factorial over 3 factorial. And I'm like, please no. And the reason why is because when you write it out here, you can see the situation is that we have 8 times everything underneath it, and a 2 times everything underneath it, and 6 times everything underneath it. If I were to cancel things out, what I could say is, let's switch over to purple here. That 6 factorial is going to cancel out with 6 and everything after on our 8 factorial. And we get left with really 8 times 7 over 2 times 1. Or I guess I could reduce now. This would be a 4 times 7. This would be a 28 is what this whole value comes out to be here. So as far as how I would do this on a normal day, on a typical day, first of all, I'd recognize that of the 2 factorial and the 6 factorial, the 6 factorial has more capacity to do damage to our 8 factorial. And then the next thing I would recognize is, well, it's easy to just write 8 factorial this way. And remember, we're saying, well, it's, this value times the last product, but the last product can always be written as a factorial. So we say 8 times 7 times 6 factorial is really 8 times 7 times 6 and everything underneath it. And this is all over 2 factorial, 6 factorial. So what I'll tell you, you can do is this. 6 factorial over 6 factorial is definitely 1. So we can see that we get 8 times 7 over 2 factorial, which is Well, I guess 56 over 2. And that's the same thing we got initially, which is this 28. So just be prepared to look at factorial expressions and evaluate them for whatever values you get. Cheers.